When you're training your Ultralytics models and want to put them into production, it's very important that we put it into an optimized framework running on a specific hardware that you can run it on in production for your project and application that you're building. So that could be NVIDIA hardware, Apple hardware, Intel hardware, all these different types of hardware that have optimized frameworks that we can convert our models into. In this video here, we're going to take a look at the MNN optimized framework if you want to run it on iOS, Apple devices and so on, where we can get a significant speed up, like up to 2x speed up, basically just converting it into this optimized framework, and it's very similar to the other ones. So if we go inside the Ultralytics documentation and just straight to the integration, these are all the different frameworks, integrations, everything that you can do, which is pretty much just hooked up directly, you can use out of the box. If we scroll a bit further down, we have videos covering most of the optimization frameworks, how to export them, how to do the full pipeline with training your own custom models. You can also use a model out of the box. So we have TensorRT, ONNX, OpenVINO, Core ML also for Apple hardware, all these different optimized frameworks, but the one that we're going to look at is MNN. So if we go inside this MNN tab under integrations, we can see that this is how we can export it into it, and this is for Apple hardware. So you can read a bit about it down here at the bottom. So it can be integrated into all different types of apps, and you can use it in all different ways as well. But the main thing that we need to know is pretty much just how do we install it, how do we set it up, and also export it with the Ultralytics models. So for example, here we can see the usage just as any other export. We just need to choose the format, and then we will just convert it directly. So this is very, very useful. We just need to specify the MNN. You can both do it in code, you can also do it from the command line tool, and this can support any of the models that we have. You can specify the batch size if you want to use half precision, so only floating point 16 bits instead of 32. It will speed up the model even more and also reduce the memory usage. Could even be int8 quantization to quantize it even further down. Then once we have done it, then you can see here that we have a function that pretty much just relies only on doing inference with the MNN. There's both an example with Python and also C++ if you're using that. But if you look at the Python example, it's pretty much just going to take the model, image, precision, the backend that we want to use, and then some threading, and then it's just going to convert it into the framework. So this is pretty much all that we have to do, and then you can run the inference with the exported model from Ultralytics. Let's just jump straight into a code editor, and let's see an example here of a video. So this is an example, and then we're going to convert it and see the actual output results. So here you can see at the top we have the optimized model, and down at the bottom we just have the raw PyTorch model. It's almost at 2x increase in inference speed, and we're not losing any detections at all. This is pretty cool. I'll just let it through here. Basically a free 2x increase. We can also see the detections. They're pretty much in line. We're detecting exactly here. As we can even see that we're getting a person detection here in the optimized version that we're not getting down here, but that could be a miss from frame to frame. This is pretty cool. All we have to do, we have this script here. You can use it on your own as well. And we're just going to use a standard YOLO11 model, but you can also use your own models that you have trained on your own. So first of all here, as we saw inside the documentation, if we go back, we need to pip install Ultralytics if you don't already have that, and we can also pip install MNN. So let's just pip install MNN. It's gonna install it. I already have Ultralytics installed, and that's everything that we need. We can then import OpenCV, time, Ultralytics for the YOLO models, and also just some annotators and colors for the output visualizations that I just showed you in the video. So this is just how we can draw the text with background, draw the bounding boxes, the rectangle positions for the labels and all that. It's just a utility function. Then we can have our inference. So we can also just run the inference directly with Ultralytics and get the results back. But if you want to use MNN directly out of the box, there's the examples inside GitHub. So we're going to use source 0, webcam as default. You can always change it. The model YOLO11 Nano, the size 1920 by 1080. So that's full HD. We get the average frames per second, so we can calculate the inference speed that we increase by using this optimized framework. Then we just open up a video capture. We have a frame looping through our video capture, just grabbing a frame, throwing it through the model, doing our prediction, and then here we are calculating our inference time. Then we can take the average of our inference time, and that's how we can do the comparison of the PyTorch model and the MNN optimized version. This is pretty much everything that we have to do. Then we just draw the text with our background. We can throw in our two models. So first of all, we run this video through, and then second of all, we run this video through with this MNN model. So if you just go down here at the bottom in our command, go inside Ultralytics, let's just use the CLI tool, export the nano version. We just have to paste it into our terminal. There we go. I hit enter. Let's just delete this comment. There we go. Now it's going to first of all download the pre-trained model out of the box. You can also just specify your own. It's gonna set up all the dependencies that you need. So we can see that now it is, first of all, it's converting it into ONNX, and then it's going to optimize it with the other one. So MNN-export success, save that YOLO11.MNN. We go into our file explorer, close this stuff. So now we can see we have our ONNX version, we have our MNN version, and we also just have the original version. So now we can run this Python script up here at the top. First of all, we can just run both of them. They will just run one by one once it's finished. So we can run Python MNN export comparison.py. Now it's going to run here on my computer, so around 40 milliseconds inference speed on average. And this is just on my MacBook CPU. This is running with the PyTorch model, and it will automatically detect and run it with the MNN model if that is converted. Got some weird detections here with a car sometimes. Might have low confidence score, so that could be filtered out. We hit Q on our keyboard and it will terminate it. So now we're going to run the second version here. Right now I'm just running it on my CPU, but this is optimized framework for iOS devices, Apple hardware, and so on. So if you run it on a mobile device, you will get significant improvements, and you can go in and run real-time detections with an object detection model on just a small iPhone. So that's pretty cool. Make sure, go in and check it out. You can use the code. Everything is available directly. Use documentation. It's just a few steps and you have it up and running. So it's so important to understand when to use what frameworks, what hardware, what internet device, what edge devices are you running your system on, and then just test out these different optimization frameworks. You can also run the benchmarking with Ultralytics. We have videos covering that, but then you can basically just benchmark different types of models, but you can also benchmark them with different optimization frameworks. Make sure that you use this. This is just a single command. It will detect all the hardware that you're running it on, set up all the dependencies. So make sure to check out this video that we have on the channel too. Hope you learned a ton of this video here. Definitely make sure that you understand it. This is very important when you want to put computer vision and object detection models into production. Hope to see you guys in one of the upcoming videos. Until then, happy learning.